Alrighty, functions f, g, and h are twice differentiable with g of 2 equal h of 2 equal to 4. The line y equals 4 plus 2/3 x minus 2 is tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. For part A, it says, oh, that was part B. Let's go to part A. Okay, well, I'm going to do part A and part B on the same one because I cannot find, can I get my slide to go back? A said to find h prime of 2, okay? If we are looking at the slope of a tangent line, we know that m is the slope of a tangent line, and that is also the derivative because this was at 2. So h prime of 2 is equal to 2/3. That was worth 1 point. All right, now part B says let a be the function given by a of x equals 3x cubed h of x. Write an expression for a prime of x, and then find a prime of 2. So they would like us to find the derivative of this. Hopefully you notice that it was a product rule. So we'll use f and g. F prime, the derivative of 3x cubed is 9x squared. G, the derivative of h of x will be h prime of x. So using the product rule, here we go. F prime times g, 9x squared h of x, plus f g prime, 3x cubed h prime of x. So that was an expression for a prime of x, and they said to find a prime of 2. So now I'm just going to plug in 2 for everything. Alrighty, so here we've got 9 times 4 times h of 2. They told us in the problem was 4. And then plus 3 times 8 times h prime of 2. We found in part A was 2/3. If you accidentally, you got a different h prime, as long as you properly used it here, you're not going to lose points again. So you could still get, even if you used a wrong answer here, you could still get full points. You may leave your answer like this, which I would highly suggest. If you didn't figure it all the way out, it would be 160. So this problem was worth 1 point. No, excuse me. It was worth 3 points. Wow. Okay, so if you determined that you needed to use the product rule, you'd get a point. If you properly found what a prime is, you'd get a point. And then if you found out what a prime of 2 is, you got that 3rd point for that one. C, the function h satisfies h of x is equal to x squared minus 4 over 1 minus f of x cubed for x not equaling 2. It is known that the limit of x approaches 2 of h can be evaluated using L'Hopital's rule. Use the limit as x approaches 2 h of x to find f of 2 and f prime of 2. Show the work that leads to your answer. So it's telling us that we can use L'Hopital's rule, which means if I find the limit as x approaches 2 of h of 2, h of x, excuse me, while we are finding that limit, we know we should end up getting 0 over 0 so that I can use L'Hopital's rule to find that limit. So that's how I'm going to start the problem. So I'm going to get the limit as x approaches 2, x squared minus 4 over 1 minus f of x cubed. All right, so we know because we says we can use L'Hopital's rule that I should get 0 over 0 at this step. So if I plug in 2, I get 2 squared minus 4. 4 minus 4 is definitely 0. So we did get 0 on the top. And then in the denominator, I'm going to get 1 f of 2 cubed. All right, so I know that in order to get 0 in the denominator, this right here is going to have to equal 1, which basically tells me that f of 2 is going to have to equal 1. So now I have just found one of the things they asked me for. They asked me to find f of 2. I just found it. Okay, so now, assuming that we do get to use L'Hopital's rule, because they did say we can evaluate using L'Hopital's rule, and I would suggest if we're going to use L'Hopital's rule, we have to say why we were able to. So we're going to say, since limit as x approaches 2 of x squared minus 4 equals 0, and limit as x approaches 2 of 1 minus f of x cubed is equal to 0, then we can use L'Hopital's. Okay, so now I'm going to use L'Hopital's. So limit as x approaches 2. The derivative of x squared minus 4 is just going to be 2x. The 4 is a constant. And then over here, the derivative of 1 is 0. And then if I have, come over here, negative f of x cubed, I'm going to do a u substitution here. U will be f of x. Du will be f prime of x. So this is going to be negative u cubed. So if I take the derivative of that, I'm going to get negative 3 u squared du. and that will be negative 3u squared, which was f of x squared, times f prime of x. All right, so now we're going to plug in 2. So 2 times 2 over negative 3 f of 2 squared times f prime of 2. I'm going to keep going here. I'm going to get 4 over f of 2. We already established above was 1. And if you establish that it was something different and you use it correctly, you're okay on this one. You can still get some points. I'm going to get negative 3 f prime of 2. Okay, so now from here, we know actually what h of 2 is equal to. H of 2 is equal to 4, so we know the limit as x approaches 2 of this function has to equal 4. So it already says 4, so we know the denominator is going to have to be 4, so negative 3 f prime of 2 is going to have to equal 1. So solving for f prime of 2, we're going to know that f prime of 2 is equal to negative 1/3. So that was what I would do on this one. This one was worth actually 4 points. If we found what f of 2 was, we'd get a point. If you, let's see here, if you, somewhere in here, you said that you knew the limit has to equal 4 at some point in time, you're going to get a point. If you use L'Hopital's rule, you're going to get a point. And then if you're able to find what f prime of 2 is equal to, you are going to get that next point. All right, this last part, it is known that g of x is less than or equal to h of x for x between 1 and 3. Let k be a function satisfying k is between g and h. For x between 1 and 3 is k continuous at x equals 2. Okay, this is going to be using something that is called the squeeze theorem. Okay, and especially when you see like things between other things, we know the limit as x approaches 2 of g of x is equal to 2 from up here, and we know that the limit as x approaches 2 of h of x is equal to, doesn't equal 4, it equals, equals 4. Equals 4 from up above too. So since we know those two are both 4 and k is in between there, then that means by the squeeze theorem, the limit as x approaches 2 of k of x is also going to equal 4. And let's see if I want to say, so from here, and since we know that 4 is k is in between there, then k would also have to equal 4. So since we found out that the limit does exist, and we found out that the value is 4, the limit equals the value, which means the function is continuous. So that one would have been just worth 1 point, so no skin off our backs if we did not get that part correct.